Good afternoon. Today we have our class of science, work and energy, Friday, October 9th. Today we're going to begin by studying what is work and energy for second year. Work and energy. Force, work and energy. What is energy? Energy is the ability to do work. The objectives of this class are what is work, calculate work done in an object, forms of energy, kinetic and potential energy, how energy changes from one form to another, and the law of conservation of energy. So what is work? Work is energy transferred through force and motion. Energy is the ability to do work. So in order to do work, we must use energy. We also need to use force and motion and direction in the same way of the motion. So work is done when an object moves while there is a force acting in the direction of the motion. The amount of work done is found by multiplying the force times the distance that the object moves. In other words, we have work, which equals W, is equal to force times distance. So we have that formula, and if force is expressed in Newton, distance in meters, the unit of work is called joules. We have a problem here that we're going to be working in class. And then we study now the forms of energy. There are two important forms of energy. The first one is called kinetic energy, which is the energy of motion. The energy of a moving object can be calculated by using the following formula. Kinetic energy equals 1/2 m times v squared. In other words, we have that mass is in kilograms and v, which is velocity, is in meters per second. We have the first kinetic energy, as I said, energy in motion. Then we have the second one, which is potential energy, and then kinetic energy again with the moving of the cyclist. We have another problem here to be solved, and then the same thing, ball with the potential energy, which is the stored energy, and ball with kinetic energy, which is the ball in motion. The second type of energy that we study will be potential. This is a stored energy of position. And now we have two forms of potential energy. A will be gravitational potential energy, which is a stored energy when work lifts an object against the force of gravity. And here we have the example of the roller coaster. This is a classical example of gravitational potential energy. So we have the formula. Gravitational potential energy is equal to W times H, being W the weight of the object and H the height of the distance lifted. Then we can say that using the example of the roller coaster, as the car travels up the coaster, it is gaining potential energy. It has the most potential energy at the top of the coaster. As the car travels down the coaster, it gains speed and gains kinetic energy too. So at the same time it is gaining kinetic energy, it's losing potential energy. So at the bottom of the coaster, the car will have potential energy again. So we have the example here. Number one will be where the roller coaster will be on the top of the hill, and that will tell me that the potential energy there is at the highest point. Then when the car starts coming down, it will gain kinetic energy, and then we go up again and down until we hit the last number, number 5, and there will be potential energy. We have problems to be solved in class using the formula. The B, or the second type of potential energy, is called elastic potential energy. This is a stored energy when work stretches or twists objects, such as an elastic band or trampolines in the swimming pool. Now we have some facts about 1 joule of energy is needed to lift a glass of milk to your mouth, and about 1,500 joules of energy are needed for one student to climb a flight of stairs, meaning that when you go from cafeteria all the way to the first floor, you are using 1,500 joules of energy. Now, how energy changes? Every change from one form of energy to another is when you heat a ball, you are transferring your energy to that ball. Think about energy transfer similar to money exchange. For example, we have a $20 bill in our pocket. The dollar is potential money, as it has the same potential to buy things. So we buy a chocolate for $2 and change the potential into kinetic. The same will happen every time we buy or change potential to kinetic money. At the end, you will have the same value of the $20, but in different forms. So no more, no less. Like money, energy neither increases nor decreases. Energy changes form and move from object to object, but the original amount of energy will stay the same. And this is what we call law of conservation of energy. We have the classical example of the pendulum. So what is the law of conservation of energy? It states that energy cannot be created nor destroyed. Energy may be changed to another form or transferred to another object, but the total energy remains unchanged. So energy is conserved. We will have here some more pictures to show you the changes from kinetic energy to potential energy and then back to kinetic energy again. Thank you very much, and we'll see you this afternoon in class.